Welcome to the Tech Trends Podcast, where we discuss the latest manufacturing, technology, research, and news. Today's episode is sponsored by Modern Machine Shop's Made in the USA podcast. I'm Ramia Lloyd, and I'm here with...
I'm Elissa Davis.
Steven Lamarca.
And Benjamin Moses. Guys, I'm sick of home automation.
You're sick of it!
I am. Well, I'm sick of how simple and how easy people think it is and how effective people think it is.
And then how quickly it breaks.
how quick everything breaks in my house.
I'm honestly impressed you've made it this far.
So I have two kind of scenarios to walk over. So I do have like a Roomba or a robot vacuum cleaner. It is a different brand. And it gets stuck on everything.
Yeah.
It doesn't like the carpets. The transition from the floor to the fireplace thingy area, it gets stuck on. It gets stuck on my Nerf bullets everywhere.
Oh, heck yeah.
And then, so I walk down every morning and I can hear it beeping somewhere. It's like playing hide and seek at 6 in the morning with where did the robot vacuum cleaner fail?
I love the idea of a Roomba, and I know they're only getting better, and I do really want one, but being that our house is 3 lazy people and a 80-pound golden doodle that does shed. Don't let people lie to you about golden doodles. They do shed. There's tumbleweeds everywhere.
Yeah.
And using our Dyson, which is a handheld cordless Dyson that I've retrofitted to take Craftsman power tool batteries. So the battery lasts longer, but now there's a new problem with that vacuum cleaner. The chamber that collects all of the dirt and debris, not big enough.
Oh, yeah.
Not big enough. Yeah. And I know a Roomba, if the Dyson can't like contain 1 floor's worth
the
of
Roomba, you have to
golden
empty it.
doodle tumbleweeds,
Yeah.
the Roomba is going to beep all the time. I'm going to get notifications to my phone probably be like, empty me.
Yeah.
So one thing that the one I have, it'll actually go to the base station and evacuate itself into another container.
That is fancy.
That is kind
And
of cool.
then-
Yeah.
And that is really cool, actually.
I wish I could teach my dog
The
that.
other problem, though, again, just to fortify any notions that we're not lazy, is I will walk the Dyson down to the garage, go out the garage, and empty the dust collector outside, specifically so none of the dust gets back inside. The problem is where I've been emptying it
It's now
is
dirty.
right next to my AC condenser units outside, and the golden doodle dander has clogged the fins, so we lost upstairs AC for a bit because it just couldn't
my
it couldn't
gosh.
exchange the heat. So
so many
like
problems.
Yeah.
don't be a homeowner. I don't recommend it.
Also, one thing I've been doing is I've been using digital picture frames, and I have a series of them, like different phases of Amelia. So I've got one in our family room and one in our like music area, and it's supposed to have a program scheduled to turn on and off during a certain time. Like we're not watching it like in the middle of the night or like at home, so
Yeah.
it's supposed to turn off. But then I bought the cheaper version. Let's be honest, I'm pretty cheap. It turns black and it just doesn't go back to the program. So I was like, okay, I can solve this. I'll do a hard reset. So I figured hard reset works. So I bought a digital plug, and I have them all running to a digital plug that I can turn on and off through a schedule. So that is my solution to cheap digital frames that don't work.
Gotcha.
I do a hard reset that does a digital reset every single time.
I think it would be really funny if you just came home and like one of the picture frames all had like the blue screen of death.
It's close.
Like
It's
this
close.
is not what I want to show off.
My grandma loves her digital picture frame because my mom and like her kids can like send pictures to the picture frame.
That's
That's
cool.
so
and
That's
and
really
so
cool.
she has like pictures of us, or like my mom will send her pictures from like things because they don't really like to leave Virginia Beach very much. So like for important life events, she'll like send pictures to her. Like my little sister's graduating next week.
I do want to hit on, because you did talk about a quick trend of like garage doors for your bread coming back.
Yeah. Yeah. I saw a video and it was like this really nice kitchen, and it was like it's like a garage for your appliances, and it's like a door that lifts up. So you have your countertop, and then like behind the countertop, like against the wall, is like a door that lifts up, and then it's like a compartment for all your kitchen appliances,
Yeah,
right?
I understand.
And I remember watching that, and I was like, my Nana had one of those in her kitchen,
Yeah, dude.
in her house that was built in the 50s,
Yep.
except it was just like one of those wood, like not accordion doors, but like garage doors.
Bro,
Yeah.
And that's where like she kept the toaster, and that's where she
was a
kept like
wooden
the
garage
mixer.
door.
Yeah. But like the way you described your grandparents, where it literally goes from the countertop all the way to the ceiling.
cabinets extend all the way
Yeah.
down from like the ceiling to the countertop, and it was caddy-cornered in the corner of the kitchen. And it was just a little garage door that you manually opened and closed. They put like liquor and bread in it, and I think I didn't realize it was supposed to be for appliances.
I think it could be for anything.
I mean,
but
the two things you need in life are liquor and bread.
They
do.
But I'm like, okay, so don't get me wrong, style in general is cyclical because it's just one of those things where it's like, okay, so these were in the houses in the 50s.
Right.
They're just coming back into style as an automated thing.
Yeah.
Like, because I would love to have somewhere to store all my kitchen appliances, but like, we've been doing that. Like, this isn't a new thing. So like, people are getting all excited about it, and I'm like, this isn't a new concept.
I think the concept of copy and pasting is going to come up a fair amount in this episode.
Yeah.
I do want to hit on one thing. Steve and I haven't talked about firearms in a while, but we are in the season of gardening and yard work. and
I got a leaf blower.
And you have a leaf blower. And
our HOA covers all of like the landscaping stuff, like, so I don't have to mow lawns. But I do have a leaf blower to blow all of the schmutz and detritus that is blown into my beautiful garage.
And leaf blowers are loud. Yeah, but even the electric ones.
Even my brushless electric one that's battery operated, it gets like really peaky and high and sharp.
Yeah.
And years ago, like when I started at AMD, there was this cool, not necessarily firearms company, but firearms industry company called OSS. Now they've changed the name to Huxworks, HUXWRX. They're a suppressor manufacturer, a silencer manufacturer, but they don't make traditional silencers that use baffles, which create a lot of back pressure, but they suppress a lot of the noise. They muffle a lot of the noise because effectively it's just a car muffler, which is a reflective muffler, as opposed to an absorbing muffler, which is typically in automotive called a glass pack or a resonator, because they're packed with fiberglass, white glass pack. But those don't. They've been using the same science to make firearm suppressors. But because a lot of firearms today are semi-automatic, too much back pressure can be not nice to the movement of the firearm. So this company, OSS, basically looked at a jet engine and were like, okay, let's redesign a jet engine so something can go down the middle of it. But I want all of the plumbing around the outside of the jet engine, which is like football fields of tubing and piping and just room for gas to expand at a controlled speed without trying to bring it to an abrupt spot or stop. And OSS, now Huxworks, created what is called the flow-through suppressor. They're not as quiet as a baffle system, but they're much better on the firearm and still hearing safe in some examples. Johns Hopkins was like, hey, these cute engineering students, they're very young, which is why the baby engineers, we're like one of the greatest schools, and we can't study because we're annoyed by all these darn leaf blowers keeping the campus super pretty. And how can we make them quieter? So I'm going to allege and say that one of them might know something about firearms and be like, can we do this flow-through suppressor design and put it on a leaf blower? And that's effectively what they did. I'm calling it right now. Allegedly, that's what they did.
Yeah. But it's a fascinating, lateral.
But now we don't have to talk about guns. We can talk about suppressors for leaf blowers.
Anyone can buy. It is interesting. I mean, we talk about the lateral transition of technology. So getting to a niche market of firearms, not defense related, but common firearms, to leaf blowers and translating gas optimization. We've been talking about
and
gas optimization.
And there's no $200 NFA tax stamp for it.
We've been talking about that for a while. So that is a cool transition. And, students still like pursuing products.
I just feel like it's like the definition, like, don't get me wrong, this is a great invention, but like, it's like the definition of a first world problem to be at Johns Hopkins University and be like, oh, it's too loud. I can't study. Like, props to you guys for doing it, but I'm just like...
I 100% get where you're coming from, but as one of the owners of one of these electric leaf blowers, they're not that loud, but where they are loud is in like a super high frequency. And they're piercing. And then they have the audacity, like my leaf blower is loud on the normal setting with the throttle all the way open, but then there's a button to put it in like hyper mode, and I can hear my hearing just deteriorate. And it doesn't feel loud, but like.
But they're not operating.
You know how like
the
a
leaf
dog
blowers.
whistle is like such a high frequency, like you don't hear any. I feel like it's doing that to me.
Yeah.
But it's taking my hearing away.
But they're not operating the leaf blowers. They're sitting in their dorms hearing the leaf blowers.
Honestly, no, I kind of respect it because I would like to give them to our HOA company
Yeah.
because every morning at around 7:30, right before my second alarm goes off, there are just leaf blowers everywhere.
It's
It's
nonstop.
Yeah.
after they've like
Yeah.
mowed the lawn that I've like slept through, but it's the leaf blowers that get
Yeah.
me every
Yeah.
time, and I'm like, love you guys, but
But
give me 30 minutes at least. I just need a little bit.
And
more.
it's really important to emphasize the flow through technology because if you think about using a baffle type suppressor on a leaf blower, it's called a leaf blower.
Right.
It's supposed to blow the leaves out of the way or in a particular direction, and the blowing act requires volumes of air to be pushed, and a baffle system would slow down the speed of that air. As for a flow through design, allows the air to keep moving, just it dampens the peaky vibrations that make all the noise.
speaking of US-based technology design, Rumia, can you tell us about today's sponsor?
That was a beautiful
I love that.
Today's sponsor. Tune in for Modern Machine Shop's Made in the USA podcast to explore manufacturing issues faced by companies making an intentional choice to manufacture in the U.S. Featuring commentary from OEM leaders, Made in the USA blends its nearly century-long expertise with a unique audio storytelling experience to shine a spotlight on the past, present, and future of American manufacturing. Find Made in the USA on Apple Podcasts, Spotify, and all major podcast platforms. Follow Modern Machine Shop on Twitter, Facebook, and LinkedIn.
Thanks, Rumia.
Anytime.
We got some testbed updates.
We do have some exciting testbed updates.
Tell me more.
Chloe and Sharab managed to get a working agent and adapter on the new Pocket NC. Frankly, took a little bit longer than we thought, but I never know like the kind of roadblocks they're going to run into when it comes to software stuff or just computer stuff, Linux. But Chloe happily was very celebratory in announcing to me, hey, we saw data come off of the robot now too.
Yep.
We don't know what that data is, but we found where the data is coming from and that it is data from the robot. So that's exciting. More development on the robot. So we've got the $115 cable connecting the gripper to the robot. The gripper works. We know what we want to do with the test bed in terms of automating it. The first step is opening and closing the enclosure of the Pocket NC, which does not sound exciting, but because we've done a lot of the preliminary, boring software stuff and the very seemingly not difficult, but ended up being super difficult, just plugging stuff in act. Now that that's out of the way, we can finally start practicing with the kinematics of the robot arm, which frankly I've been doing. So everybody else has been, putting in their blood, sweat, and tears just so I can finally play with the robot. Hashtag privilege. And so I've been working on finding the movement path that the robot is going to do to open and close the enclosure. And Ben, you've made a design for some soft jaws that will go on the gripper, because while we have the gripper and it's finally bolted in and plugged in and working, the gripper does not actually have things to grip anything with. It's got joints, but it has no fingers, for the lack of a better term. It has no soft jaws on it. So we need to have soft jaws manufactured. Georgia Tech, Kyle Salibi, was very willing and it's ready at any moment for us to send him a file and make us some quality soft jaws, probably with some cute branding that he's going to put on there as a surprise for us too, because he's amazing. But Ben's figured out a design that we're going to do for the soft jaws, and we've also determined that we are going to submit the design to the Fairfax County Public Library System.
Nice.
Who has a makerspace of an undisclosed location because they don't want people showing up, I don't think. But they do say that you pick the library branch that is closest to you, and we will deliver the finished part there. But don't come to us.
And it's useful to go through the experiment because it's been 1,000 years since I designed anything in CAD. So this is more of a test print. And then Georgia Tech will come up with the production version. So check fit and finish. So we're going to 3D print the fingers.
Yeah.
Make sure the interfaces work because the interface is going to work for the raw material and opening, closing the door. So once we verify that works for like $20, then we can reach out to Georgia Tech to see if they can do. We do have to modify the design a little bit.
What's $20?
I have a feeling the cost of the gripper, the fingers, is going to be like $20 or less.
In hardware?
No. Printing the gripper. They're going to charge us.
I thought
The library will charge us.
Well, the library said it was free on the website.
They'll charge us for the material.
Oh, okay, they do.
They charge for material, not time.
That's
Gotcha.
fair.
Yep. And we do have extra hardware, so we have it.
That makes me feel better because I was under the impression that the entire thing was going to be free, and it's like, this is not sustainable. I'm glad my taxpayers are coming back to me, or taxpayer dollars are coming back to me, but this doesn't seem sustainable.
It could be Fairfax taking a different approach because there are a lot of different rules in Loudoun County. So Loudoun County, when I show up, I have to pay for raw material used.
Okay.
So yeah, this is an iterative approach. We did as much simulation as I could, verifying everything will work. But we need to physically see it because the path of the robot, it's kind of hard to simulate that now with all the models that we have. I think it makes sense to get right to the physical space and start doing
This is interesting because this is America. Everything costs money. But at the same time, it's like, you would think a government organization, even state government, would be like, hey, if we're providing a service, we have a price tag on it. You would think that would be like one of the first things that they put in there. I went pretty thoroughly through all of the documentation that they have on the website, and I didn't see anything about cost.
We'll find out.
Maybe that's how Loudoun County stays like the richest county in the United States.
I did see the one line in the not FAQ, but like just the guidelines, the terms and conditions that said, right now, you cannot bring your own filament. You use our filament. And you don't even touch the printer. We have operators to do this.
Yep.
But right now it costs money. It's just on a first come, first serve basis. But if demand increases and backlogs get more and more dense, then we may put a price tag on it. Yep. But as of right now, I think it's free.
I'll find out. So we got hardware coming in, got nuts and bolts, or bolts and dowel pins. A drill, because since we're 3D printing it, I undersized the clearance hole for the dowel pin because I don't trust the 3D printer to get it to the size that we need. So we're going to drill that back out and then glue the dowel pins in. And that's one of the modifications when we get to Georgia Tech is modifying the design so they can go to more machining tolerances and standards as opposed to 3D additive plastic printing.
Yeah.
Cool. I'm excited. I want to get back to getting to automation. So there was an article or a roadmap published. The 2024 edition of the U.S. Robotics Roadmap points the need for federal coordination. This is published on the Robot Report. And this is published from, I think USC helped organize this. And it's basically taking a look at robotics in the U.S. and what are the challenges or roadblocks current state as of this year. And to be honest, I have a lot of things I disagree with overall. So there are three main bullet points. The first one, it calls for more federal coordination. I don't think that's really needed. On a couple of layers, it's asking for more federal coordination. So you already have the ARM Institute.
Yeah.
And you already have MEPs at every state.
Yeah.
Federal coordination adds cost, oversight,
slow red tape, bureaucracy,
where the underlying problem is more of adoption as opposed to technology generation. I think that's where they're headed at the federal level is that I think they're headed more towards technology development for robots, which actually gets to one of the underlying things which I disagree with a lot is it talks about robots.
Yeah.
Robots is not the problem. Robots is a subset of automation in general. So I think their approach on focusing on it's very myopic view of focusing on an underlying technology where there's other ways to increase productivity. And that's one of the other bullet points it talks about later is, can the U.S. regain robotics leadership? I'm like, what is the point of gaining robotics leadership? I think the focus should be on, can the U.S. get back to higher levels of productivity through automation?
Yes.
I think they're missing a boat on a lot of bullets here.
I think there's two things that I want to bring up. Number one, when it came to the guide did, or the roadmap did list other competitive countries. They didn't mention South Korea.
That's a big
How
miss.
do you not mention South Korea as not being, or not mention them as a robot powerhouse, which they are.
Yep.
They are growing faster than any other country, and you didn't mention them at all.
Yeah.
Like that just questions the credibility of this roadmap and who wrote it. Sorry, I don't mean to get spicy. But and then the second thing is okay, you're calling for all of this federal coordination that is going to slow things down. And people are going to question that it's going to slow things down. Why aren't we transparent about risk?
Right.
We need to be transparent about risk here, so you can say that, okay, these are the risks, but this is the risk that it would be avoiding, which is the monopolization of a robotic or automation technology, which is absolutely what we should be worried about too. We don't want literally everybody, including the U.S. federal government, paying royalties to some company that has the monopoly on some sort of automation technology.
Right.
That is absolutely bad. We are heading in that direction. There's no doubt about it. But you're not going to solve risk by introducing more risk.
Right.
Well, and I think I might get canceled for saying this, but
Do it.
I think it's a very American way to look at robotics, to really focus on how it's on the competitive aspect rather than the collaborative aspect.
Right.
Because all of us working together can get a lot more automation and robotics put into place rather than competing and seeing who can do it first. Right. But that is just a very American way of looking at it. And I think that's been true since the space race, yeah, because I think there's a lot more to be achieved being collaborative than competitive.
And they hit on the last bullet that I saw in the article was a national strategy for robotics. And I get the sense that what they're trying to do is copy and paste what other nations are doing. That works well for them, but that doesn't translate to the competitive, as you mentioned, the capitalistic side of the market, where what worked in Europe or other countries that are heavily focused on national businesses. Everything here, there's not a national business, right? There's individual companies that are thriving to grow and compete against each other. And I think we're missing the boat a little bit in terms of how things work and transitioning that into a more effective environment.
Yeah.
Because Steve, to your point earlier, we talked about the CHIPS Act, and that has precedence and value. Like Intel and some other companies are making factories. States are getting money to offset subsidies and things like that for the local level. But a lot of the lessons learned from the automotive transition from the 70s and 80s are kind of being missed a little bit. And I feel like this is another boat where we're copying and pasting what other people are doing, but not translating it to what should work in the U.S.
Yeah.
So interesting article. I'll give it a quick read. I do want to talk about 3D printing in space, though.
Yeah. So we have officially started 3D printing metal in space on the International Space Station.
Nice.
So this is an article from TCT Magazine. And let's see. So the European Space Agency, the ESA, they've declared has declared an additive manufacturing first as a giant leap forward for in-orbit that's a mouthful, in-orbit manufacturing. So they did an S-curve test line, which is literally just exactly what it says, which is just 3D printing the shape of an S in metal, but they did it. And that was in space, which is pretty cool. They are using the direct energy deposition process in
CNC
space.
welding?
Yep. So they're in stainless steel wires heated by a high-power laser. It operates in a fully sealed box, preventing excess heat or fumes from escaping. And the process is overseen entirely from the ground.
That's really cool.
So it is remotely operated the entire time. All the onboard crew has to do is open a nitrogen and venting valve before the printing starts.
Yeah.
So you don't have to be a 3D printing expert to go to the International Space Station because they're taking care of it from the ground.
That is so cool.
Yeah.
Lean manufacturing in space.
I think this hit on a bunch of really interesting topics. So, like the impact of gravity on 3D printing in space, that's pretty important. Printing at point of use, that's something obviously we're very interested in. But also the fact that they're remote manufacturing, right? It's not the fact that they have astronauts printing, which technically they are.
Yeah.
They're operating the machines. But realistically, all the data and everything is being, zipped up and transmitted to the space station to print remotely. And I think that's a very fascinating scenario.
Yeah, and so it says the project known as Metal 3D started in 2016 when the ESA awarded the contract to Airbus Defence and Space. Wow. And they spell it the European way with the C for defense. And so while polymer 3D printers have been on board the International Space Station and printing parts since 2014, this metal technology arrived on board the International Space Station in January. And the aim was to create the first metal 3D printer to operate under microgravity. So,
thank God it's Airbus and not Boeing.
I mean, fire in space is scary. Let's be honest. A hot laser in space. I mean, the risk and thought processes to get to this point is fascinating to me. So
yeah,
that's cool.
But now they can repair like satellite parts and stuff.
Yeah.
And all that stuff.
It's really inspiring. Like it makes your imagination race, wondering like what's next.
It took less than 10 years to get there.
When are we going to
Which is pretty
3D print
amazing.
stuff on Earth from a satellite?
Other way around.
Just
I feel like that would-
no. I mean, like the material
the
and
material,
the energy
yeah.
source is in a satellite, and it's making something on the ground.
100
years out, I'm gonna freeze myself. I want to see it.
I feel like we're not that far from it.
Really?
I don't
I'm more interested in you freezing yourself. I want to get into that in the next episode.
Yeah. Gonna
I
hang
feel
out
like
with
we're
Walt
not
Disney.
that far from. I feel like we're not that far from it, but we're really far from it in terms of government oversight and bureaucracy.
Steve, tell me about AI and LLMs.
Okay, so last week, David Anderson reached out to me on LinkedIn, being like, "Hey, saw your ChatGPT article about like using ChatGPT in manufacturing. I wanted to reach out to have a nerdy conversation with you about LLMs and AIs, but with a focus on manufacturing." And David Anderson, he works for I think the company's called Angora, or that's just the name of his LLM, his team's LLM. But he is a partner or resident, not a partner. He's a resident at Autodesk on the East Coast, so up in Boston. Visited there during the pandemic, season 1, road tripping with Steve. Just check it out. And he's there working on this LLM like ChatGPT, but specifically for manufacturing. So here's some of the bullet points from our conversation. Angora is an AI assistant for manufacturing and engineering, of which there's an enormous amount of documents, books, just information and data sets in general that instead of being like ChatGPT or Gemini, which has access to a blocked off time frame of the internet, instead Angora has just been feeding their chatbot, their LLM. What is the name? Where is it here? Their Chattalog. With everything that they can get their hands on with respect to manufacturing. So every edition of the machinist handbook is thrown into this LLM. So you can ask it all of the things. One of the demonstrations that he did for me was he asked Angora, make me a table of all of the specs of the different types and sizes of socket head screws, socket head bolts, and it made a table. And then I was very impressed by that. And I was also like, isn't this seems a little like something that ChatGPT could do? And then he threw the curveball at me, and it was like, all right, now make me this table in JSON.
That's cool.
And it did that, and it's cool because they don't have he doesn't, his team, which again is just a residency at Autodesk right now, doesn't have the computational power that OpenAI has, or Google or Microsoft has. So it took a little bit of time to think, and like one of their next steps is, we're also working on creating an error. So like sometimes the thing will just start thinking, and it will keep thinking,
Yep.
and it will never tell you that it ran into an error.
Sure,
It'll just keep
sure.
thinking. It'll just leave you like twiddling your thumbs. It's like, we're working on building that.
Yeah.
But
I do like so the domain specific knowledge set that it has.
you told me about this word.
I think it's very important because it builds confidence and knowing that, if they use a machine's handbook, you can ask, what's the clearance hole for a quarter 20 bolt? And then obviously let's give you a starting point and you can check the machine's handbook to verify. You should always trust but verify. But the fact that, it has that being able to convey domain specific prompts to the tool and knowing that the training set is from that training set, I think is very important. And especially for manufacturing and the domain specific vocabulary that's required.
Yeah. I also think it would be really, I love the idea of being able to go to an LLM, a chat, and be like, okay, I'm using a 1/4 inch, 0.030 corner radius, 3 flute end mill, and I'm trying to machine some brass to make a watch dial. What speeds and feeds should I be using? And then it spits out the speeds and feeds. And it's like, oh, sorry, I need to specify this isn't machining brass. I'm not doing like real, like standard brass.
Yeah.
And it changes up the speeds and feeds for you.
Yeah.
But more importantly, and I forgot to talk to him about this, is like, it would also be really cool to see an LLM that can also cite its sources.
Right.
Can tell you where it found it.
Yeah.
Because I remember when I started college, when I started my undergrad, I actually went to part of orientation was some teachers like pulling us into a massive classroom, a lecture hall, and basically yelling at us about, hey, don't use Wikipedia. Wikipedia is not a legit source, so don't be writing your essays up in here and using Wikipedia. It's like, but Wikipedia has sources.
Right.
Yeah.
If I use Wikipedia, obviously I'm not going to cite Wikipedia. I'm going to cite Wikipedia's sources.
Right.
Because those are legit. Wikipedia might not be, and yeah, it's somebody can influence bias on it. And it's like, yeah, if you're an idiot, like if you're dumb, so I'd really like to see an LLM that can cite
I just
sources.
wanted to say that as someone who has tried to edit our IMTS and AMT Wikipedia pages, they're real strict about it.
Oh, yeah.
Like I tried to copy stuff from our
Yeah.
website and they were like, you can't do that. And I'm like, I work for the company. Like it's not like I'm a random person using this information. I represent the company and I'm putting it on there and I'm quoting it, citing it, all that stuff. No. They took it all down.
I'm LinkedIn verified.
Yeah, they took it all down. So Wikipedia, because there are people who literally spend their lives are just editing
those
Wikipedia.
moderators are real.
But
And frankly, I'm glad they are.
Yes.
I'm very thankful that they exist.
But that's part of why Wikipedia shouldn't be like this big taboo thing. Because my professor in college actually said, she was like, shout out to Dr. Linnea Chapman King, one of my favorite professors. But she said, she was like, look, you don't cite Wikipedia. She's like, but use Wikipedia as a starting point and then go through the sources that Wikipedia has and use those sources because those are probably going to be primary
That's
sources.
all good professors have to say.
Yeah.
That's the difference between, a professor that's just trying to get a paycheck, which is like, grow up. That's a bad way to get a paycheck. Or somebody that genuinely wants to teach and
She's
like make
Great
education
professor.
better.
Yeah.
So you do hit on a really interesting point back to AI. That is still a problem on the largest set of applications of artificial intelligence. Show me your work. Back to your the math teacher asking, how did you get to your answer? Everybody wants to know that, and I feel like in the next couple of years we'll get to that point because there's still lack of trust in general. The only way you're going to build trust is have the model start showing you, or to your point, Steve, if there's error, like if the LLM or AI tool can't find the answer for you and it kind of guesses, tell me you're guessing.
Yeah.
And that's where I hope to see more iterations. Let's look at the domain specific stuff.
It'd be great to have like David Anderson on this podcast because he's very down to earth and like these are all points that would resonate with him a lot. He wanted me to also mention that they will be releasing a public beta soon that anybody can use. With the caveat, not really caveat, but like with the disclaimer that's like, listen, you shouldn't use this to program anything. Consider all of the results that you get as a guess. Do your due diligence to make sure what it's telling you is correct. And please, for the love of God, do not use this to program anything. No, don't ask it to make lines of G code for you.
Yeah.
It can. Don't do it, though. Or if you have it do it, God forbid, just don't throw that line of G code into a machine without simulating it first.
Yeah. Awesome, guys. Romeo, where can they find more info about us?
amtonline.org/resources. Like, share, subscribe.
Bing bong.